This lesson is discussing slope. The slope of a line is how much it rises or falls as it's moving left to right. So when it's going up from left to right, that is a positive slope. When it's going down from left to right, that is a negative slope. If it's going across like a horizontal line, that is a zero slope. Because if I were to calculate it, which I will later on, I would have 0 over some of their number, which reduces to become 0. And if I have a vertical line, that would have been a number over 0, and that reduces to undefined. So if we're given a graph, we can use rise over 1. So that means from one point to the next, we would first calculate how I moved up or down, and then I would calculate how I moved left or right. Rise first, run second. So in this one, we would go up 1, 2, 3, 4, so that's a positive 4. And then we would go right 1, 2, 3, 4, 5, so that's a positive 5. So that would be 4 over 5. For the second one, to get from P to Q, I would fall first. So I'm going down 1, 2, 3, so that's negative 3. And then over to the right, 1, 2, 3, 4, 5, 6. So a negative 3 over a positive 6 would reduce to negative 1/2. The other way we could do it, and the more common way we're going to do it, we're going to use a formula. It's the slope formula. M is the letter we use for slope, and it's going to equal y2 minus y1 over x2 minus x1. So that means the change in the y's divided by the change in the x's. Using the points A and B here, x1 and y1, x2 and y2, if I subtracted my y's, that would be 6 minus negative 2 on top. I just lied to you. Those are the x's, and I'm immediately doing it wrong. Let's try that again. The y's, negative 1 minus 5 over the x's, 6 minus negative 2. So that's a negative 6 over, that turns into plus 8, which turns into negative 3 over 4. For 4, we're going to find the slope of GH. So again, M will equal, y's first, 7 minus negative 3, and negative 6 minus negative 11. So this negative becomes plus, 7 plus 3 is 10. This negative becomes plus, negative 6 plus 11 is 5, and 10 over 5 turns into 2. Parallel lines are lines with the same slope. So we already know that lines that are parallel will never intersect. They are coplanar lines that never intersect, but now we know their slopes will be equal. Perpendicular lines, which were lines that intersect to form right angles, are going to be lines with opposite sign reciprocal slopes. Or 0 and undefined. Because one was a 0 on top and one was a 0 on the bottom. So they reduce to become perpendicular. So here are some examples. We're looking for the opposite sign and the reciprocal. So 3 over 4 is positive, so the opposite sign will be negative. And if I take the reciprocal of 3 over 4, I have 4 over 3. For number 2, 2 is really 2 over 1. So this was positive, so the opposite is negative, and the reciprocal is now 1 over 2. For 3, we have negative 7/8. So this was already negative, so my opposite sign reciprocal will be positive, and 7 over 8 flips to 8 over 7. 1 is really 1 over 1. The opposite sign would be negative, and if I flip 1 over 1, I still have 1 over 1. So basically, the opposite of 1 is just negative 1. And then my last one here, I have 0 and something. So 0, we said before, is perpendicular to undefined. We can use the slopes of lines to tell whether they are parallel, perpendicular, or neither, because it doesn't have to fit one of those relationships. So down here, this M and then parentheses is saying we're going to find the slope of line AB, the slope of line CD, and then we're going to describe them as either parallel, perpendicular, or neither. Right? Parallel was equal, perpendicular was that opposite reciprocal, and neither if it doesn't fit either of those. So for the slope of AB, I'm going to take the y's, 6 minus 3, over the x's, 2 minus negative 2. So this is 3 over, those negatives turn into plus 4. And that's as reduced as the slope of AB gets. Now I'll find the slope of CD. So that's going to be 3 minus 0 on the top, and 3 minus negative 1 on the bottom. Minus minus becomes plus, 3 plus 1 is 4, so I get 3/4. So comparing my two slopes, they're equal to each other. That makes these parallel lines. For our next problem, same thing, we're going to do the slopes of AB and CD. So slope of AB, 4 minus 2 for the top, 5 minus 0 for the bottom. So that's a 2 over a 5. For the slope of CD, 3 minus 8 for the top, 3 minus 1 for the bottom. So this is going to be a negative 5, and this is going to be a positive 2. So looking at my two slopes, one is positive, one is negative, so they're opposite signs, and 2/5 and 5/2 are the reciprocals. So these lines are perpendicular. You can either write the word or use the symbol. Remember, our symbol looked like an upside down T. So here we're going to use our slope to determine if lines A, B, and CD are parallel, perpendicular, or neither. So the slope of AB, 6 minus 8 on top. Oops. What happens when I jump the gun and put two lines? 2 minus negative 1 on the bottom turns into plus. So this is going to be negative 2 over 3. My slope of CD, 3 minus 2 for the top, 3 minus negative 1 for the bottom. Turns into a plus, so this will be 1 over 4. So these two slopes have absolutely nothing in common, so we would call this neither. All right, there is one more here for us to try together. You can pause if you'd like and give this one a try. Answers are posted on Google Classroom. All right, and now let's apply this to parallelograms. We are given 3 vertices of a parallelogram. W is at -1, -3. X is at -3, 2. And Z is at 4, -4. If it's supposed to be W, X, Y, Z, W connects to X connects to Y connects to Z, and Z connects back to W. So we're looking for where Y belongs. Since a parallelogram has opposite sides that are parallel, I can use the slope of the bottom line to make a line at the top with the same slope. So this one was down 1 and to the right 1, 2, 3, 4, 5. So from X, if I go down 1 and then over 1, 2, 3, 4, 5, that is where my point should end up. So my point of y would have been at 2, comma, 1. So here's one more for you to try. You can pause. Answers are posted on Classroom. But that is the end of our notes for slope.